Good day, everyone. Today we're with Dave Cheney. We're gonna talk. We're gonna talk about names today, and I don't think I need to present Dave Cheney at all in Go community. I think it's a backward. Go community should present itself to the Dave Cheney. Everybody knows you, everybody loves you, and especially everybody loves your incredible articles. I agree with every your article. It's a rare case when I agree with something fully, but that's what it is. Without further ado, everybody's waiting for your presentation, Dave. That's why I'm leaving you there, and hope everything goes smoothly.
Well, thank you very much for the introduction. And thank you for having me here at GoWayFest. Maybe one day when all this is over, we'll all get to meet in person. But for the moment, let's talk about this presentation. So today I'm going to talk to you about possibly the most contentious topic in the Go community. Can you guess what it is? Are we going to talk about dependency management? Maybe we're going to talk about error values versus exceptions, maybe a bit of monadic error handling. Maybe we're going to talk about generic programming. Well, actually, it's none of these, because as Artem introduced me, we're talking about names. Because of all the critiques that are leveled against Go, this right here on my screen is the hill that most people choose to die on. They say, what's with all the short variable names? Now, I reject the premise of this question. I think it creates a false dichotomy that all names should either be long or short. Because choosing a good name is more than just choosing its length. It's more than just choosing the name of any variable, because variables aren't the only things that we can give names to in our programs. We have receivers, formal parameters, return values, constants, functions, types, methods, file names, even packages. These are all kinds of identifiers that we can declare in our Go programs. And they all have an impact on the maintainability of the program. This is the key here. So let's start right at the heart of the matter. Let's address the question that I opened with. Long variable names or short ones, which one is best? Well, the thing is that that's a trick question. Because even when we're talking about variables, there are several different kinds. We have local variables, formal parameters, we have return values, struct fields, and even variables at the package level. So these are all different kinds of variables you can declare. Now, there is an overriding principle which guides the length of choosing a good name, and that is the distance between the declaration and its use. The larger that distance, the larger the identifier. Now, I didn't just make this up. These are not my words. These are Andrew Duran's words, the first Go advocate we had. So let's talk a little bit about the values that inform this advice. In Go, we give short names to variables whose lifetime is limited by their enclosing scope. We give longer names to variables that have a larger scope because we expect to encounter them in the future, perhaps a long time in the future. Now, computers don't care about the names of variables. To a CPU, they're all just memory addresses, they're just numbers. So the names are fundamentally for us, the author and the reader of the code. And so when we choose a name, lengthy bureaucratic names need to justify themselves. The longer they are, that length has to bring more value to the reader. And it's important to recognize that even within this framework of short scope, short name, long scope, long name, I think it can be more contextual than this. And fundamentally, if you're obsessed with a local variable, you might be missing the larger picture that perhaps there's too much going on in your function. Because fundamentally, is this for index equals, fundamentally more readable than this? I argue it's not, because likely the scope of I, or index for that matter, is limited to this body of the for loop you see on the screen. And so that extra verbosity of saying index over and over again adds little to the comprehension of the program. Now, if you have a loop nested within a loop, it's inherently harder to comprehend, regardless of the name of the loop induction variable. And if you find yourself with so many nested loops that you've exhausted your supplies of i's and j's and k's, it's probably time to break your function into a smaller one. Let's look at a slightly larger piece of code. In this example, P, about 3/4 of the way down the page, lives for a very short amount of time. It's only referenced on the following line. And so for any reader who's interested in the effect the value of P can have, they only need to read those 2 lines. Now, by comparison, people is declared in the function parameter. It lives, therefore, for the entire body of the function and is referenced 3 times over 7 lines. The same is similar. This is similarly true for sum and count. The reader has to scan a wider number of lines to locate them so that we give them more distinctive names. Now, I could have chosen S for sum or C or possibly N for count, but this would have reduced all the variables in this program to the same length, and thus perhaps of equal importance, when really they have differing levels of importance. Now, I could have chosen P instead for people, but that would have left the problem of what do I call the induction variable that we use in for range? And the singular person would have looked odd, as the loop induction variable that lives for very little time would have had a longer name than the slice it was derived from. So that's a bit wordy, but all this is to say that naming is contextual. Now, early programming languages required the declarations when you had a procedure or a function to occur at the top of the function. This was an implementation restriction, but some people mistook it for good practice. Now, Go style, on the other hand, suggests keeping declarations close to where they're used. And a corollary of this advice suggests that variables, and by extension functions and types and even packages, should be arranged to avoid creation of unnecessarily verbose names. You want to keep related concepts close together. And the reason you want to do this is so you can avoid the need to leave yourself breadcrumbs for how they relate in their names. If their use is obvious from reading on the page, rather than having to maintain a scaffold through names and path names and long variable names to tie those concepts together because they're spread out across the code, that necessarily inhibits readability. Another concept that I want to put to you is one like this. You don't call your pet Frank Dog or Java Cat or Bob Fish. And for the same reason, you shouldn't include the name of the type in your variable's name. Look at an example. What's good about this declaration? Well, we can see that it's a map. And we can see that it has something to do with the user's type. So that's useful. But more fundamentally, user's map is a map. And being a statically typed language, Go won't let us accidentally use it where we intended a different type. Now, let's consider what happens if we go on and follow this pattern and declare a few more variables. We have a map of strings to companies and strings to products. Now, these are all maps of strings to different types, And again, we know that they're maps. It says it right there in the declaration. You can see it on the right-hand side of the screen. We also know the declaration prevents us from using one in place of another. This isn't Python, this isn't Ruby. You can't accidentally use the wrong type and it'll just kind of get smooshed together. So in this situation, I'm going to argue to you that the map suffix in the variable's name isn't improving the clarity of the code. It doesn't tell the reader anything more than they already knew. It's just adding extra boilerplate. So what if we were to, as an experiment, do this? We take away the suffix, and it leaves us with the more concise, yet I argue equally descriptive version. So my argument to you is, if users isn't descriptive enough, then users map wouldn't be either. Nothing about the suffix map fundamentally made that more descriptive. And repeating the type of the variable in its name isn't going to make it more type safe. In your program, each concept should be represented by a single predictable name. Brian Kernighan says, choose variable names that won't be easily confused. The reader should be able to predict what an identifier represents and how it should be used the first time they encounter it. When you encounter that identifier again later on, they should be able to assume that it hasn't changed meaning since the last time you saw it. So convention breeds predictability. For example, if across a code base, you sometimes refer to a database handled by D or DBase or underscore DB in a field or database sometimes. Compare this to consolidating on just using DB and use it consistently across parameters, return variables, local declaration, even struct fields. Doing so promotes familiarity. When the reader sees DB, they know that it's an SQL DB. The name of the variable implies its use. And the only thing they need to know is, was it declared locally or was it provided to you by the caller? In most cases, they don't even need to know that. There are plenty of examples of this in programming. I and J and K are universally the loop induction variables for simple for loops. N, when we see an N, it's usually a counter or an accumulator. We see a V, that's usually the shorthand for value in a generic kind of encoding function. Like we just take a value, any value, just call it V. K is almost universally the key in a map. A and B are generic names for parameters where you want to compare some properties of variables that have the same type. So maximum of A and B. X and Y, similarly used in for local variables. S is almost always the shorthand for string. And collections, when we talk about them, we make them pluralized because they contain a set of things or an array of things or a map of things, but a collection of things. So that's some arguments for you about variable names. Now I'm going to move on from talking about variable names to talking more about function names, because at the end of the day, I care more that your functions are short and well named than I care about the names of transient local variables within those functions. We can fix naming issues within a function without breaking an API. But if we have to rename functions or methods, that's when things get serious. So fundamentally, following the same logic, prefer short functions and give those short functions simple short names. This advice comes from if the operation of a function is so complex that you can't find a simple name for what it's doing, maybe the problem is not that you can't find the name, but the problem is deeper in the design. If the design does not promote to you a suitable name, a simple suitable name to describe what this function is doing, it may be doing too much, or you may not really know what it's doing. might have been kind of painted into a corner by that design. I'll put to you an argument that functions should be named for the result they return. Sam Gardner writes, if you don't know what a thing should be called, you can't know what it is. And if you don't know what it is, you can't sit down and write the code. So a name of a function is foundational to knowing how to write that function. Let me give you a little example. Consider this example. We want to write a function that adds two numbers and returns the result. Simple stuff. Which of these two names do you think is better? You might be thinking add, because that is what the operation is. We want to add A and B. But let's look at it in code. When we read it, we read it like we would read a English or Romantic script. Result equals the add of 37 and 9. The add isn't a verb. But if we look at the second version, the result equals the sum of 37 and 9. Summation is a verb, it's a doing word. And so I argue to you that while add might be the operation, sum is the result. The result is the sum of 37 and 9. When you have several functions that do related things, my suggestion is to give the shorter name to the one that people are going to use most often, the default or the de facto choice. Convention, and perhaps the fear of the unknown, will drive users who are first using this API that just want just tell me how to use it, the default behavior. They will gravitate towards the shorter name. The shorter name seems simpler. I don't want to think about timeouts. I just want a new client. They're going to call new client. And when you have, you leave the more specialized behavior of I know I actually want a special timeout. You use new client with timeout. There is a kind of limit to this kind of pattern here of creating many constructor functions or many functions for the different parameters they take. And I talked about this back in 2014 at .go. When you have this list of alternate invocations and it becomes unwieldy, consider something like functional options to reduce the footprint of the API without overwhelming your users with choice. gRPC, a lot of the newer APIs we see coming out of Google, GoCMP, follow this pattern, this functional options pattern that Rob Pike pioneered. I think it's a really good way of keeping your names short, concise, and descriptive without overloading the user with a million different options for different permutations. So we talked about functions. What about methods? Now, we're all Go programmers here. We know that methods are just functions with a receiver as this magic pre-declared parameter. So if methods are just fancy functions, should the rules for naming that I just went through be the same for methods as well? Let's have a look here. Let's use the same example here. We have the world's worst big decimal type, has some dollars and some cents. And again, we're left with the choice of, do we call the method add or do we call the method sum? Let's look at it in code. Now, when we're talking about a function named sum, that seemed to be the right choice. But let's read it here. Total.sum, $20.05. Should that be returning something? Are we ignoring the return value? Compare that to total.add. Add to the total $9.99. So it seems that when we talk about naming functions what they return, perhaps we should name methods for the operation that they perform. Okay. I'm going to move it up a little bit. Moving up the stack, let's talk about the names of packages. Samir Ajmani writes, a package's name provides a context for its contents. Makes it easier for the client to understand what the package is for and how to use it. Well-named packages make it easier to find the code you need. So what Samir is saying is writing a good package starts with choosing a good name. Name your packages for what they provide, not necessarily for their contents. Another really important thing from the view of a consumer of a package is that from their point of view, the identifiers inside that package include the name of the package. So, and you should exploit this property for all of those exported symbols. Variables, functions are all thought of from the caller's point of view for them qualified name, package.symbol. The get function from the net HTTP package becomes http.get when referenced by another package. The reader type in the strings package becomes strings.Reader when it's imported into another package. The net error interface from the net package is clearly related to network errors. It's right there in the name. So this is a really useful property that we get for free with the package system in Go. Really, you should really leverage it because it can give a lot of information to the reader in a very concise way. Now, on the flip side, we have packages like base and common and util and helpers and tests and all that rubbish. In my experience, generally these types of packages are found in projects where they've developed very deep package hierarchies and they've wanted to share functionalities without encountering import loops. And so to do that, they've had to extract these utility functions into a new package to break that import loop. But because this package fundamentally stems from a design problem in the code, its name doesn't reflect its purpose. It's just a name that they had to make up because they broke this code out into another package to break the import cycle. And so they get rubbish names like base and common and util. So when I'm faced with this problem in projects that I work on, there are really two choices. The first one is look at where the callers of these util helper packages. It generally turns out that they don't have many users across the code base. They generally only are called by one or two places. And so in that case, consider maybe just duplicating the code. I know this is heresy in a world of dry, but if we consider Sandy Metz's very well thought out advice, a little duplication is far cheaper than the wrong abstraction. And in places where those utility functions are used in many places, and we see this as the reason for many of the packages in the standard library, instead of giant monolithic utils packages, break out the functionality into very targeted packages. For example, we have path, file path, we have the strings package, and they all do very specific things. It's okay to import two packages. Doesn't cost you anything to have one more import line. Now, I believe that all of us programmers share a strong desire to apply taxonomy to our work. However, in doing so, I believe that many programmers want to do this by trying to find the things that are different. They try and find the differences between two things so they can be separated, segregated, and therefore classified. I think to write successful code, you need to look for the things that are similar and combine those things, combine things that share a similar purpose into a package. The example I love to give is Brad Fitzpatrick's HTTP package. The net HTTP package does not imagine if it was written in any other language apart from Go. You would have a client package and a server package and a utils package and a messages package. This is how I've seen it played out in many other languages. But instead, in Go, we just have one package called HTTP and has both client behavior and server behavior and shared logic between it and transport. Because fundamentally, these are all this is all code in service of the idea of HTTP. So Go packages are for avoiding namespace collision, not for creating taxonomies. While we're on the subject of perhaps don't name your package v2. I know that we're in the situation forced on us by Go modules. They force us to put version numbers in our package names, and I think this is a terrible compromise. But where you can, and I appreciate that it's not always possible, move that v2 up. Don't call your package v2, call your module v2, because fundamentally, what's the name of the what's going to be the name of those variables and types from the first package? They're going to be v2 dot something, and it completely wastes the ability of using the package name descriptively. The last piece of advice I'll give is don't let package names steal good variable names. For example, the context type in the context package is obviously context.context. And this has made it impossible to use the word context as a variable or type in your program. This just won't compile. This is why everything that uses a context calls it CTX. This is also the reason why the database SQL package is named the way that it is. Even though this leads to slightly convoluted types like SQL.con, when really it should be a database.con. This leaves the identifier database for use for all the people that use that package. Okay, I'm getting close to my time, so I'm gonna wrap this up. Choosing a good name starts at local variables, but it extends all the way to your package declaration. Naming isn't just about variables. All good names share several characteristics. Brevity. A good name is concise. It carries a high signal to noise ratio. Precision. A good name is accurate. It accurately describes the things that it represents. And consistency. A good name should be predictable. Whenever you encounter it, it should feel familiar. Use the smallest scope possible. Declare variables close to where they live. Short variable names work well when the distance between their declaration and their last use is short. So prefer single letter variables for loops and branches, single words for parameters, return values, multiple words for functions, and package level declarations. As the scope gets bigger, so too do the declarations. And remember that repeating the type of the variable in its name is not going to make your program more type safe. Methods mutate state. Functions transform data. These are different operations. Name them appropriately. Functions should be named for the results that they return. Methods should perhaps be named for the action that they perform, the operation. And as a piece of advice that I've stolen from Dave Thomas, be wary of conjunctions. Be wary of the word and, because they indicate that a single function or method is doing too much. Name your package for what they provide, not what they contain. And try to avoid creating package taxonomies. The goal is not to split your code into as many possible pieces. The goal is to find the commonalities and bring them together. There are two parts to each exporter identifier, the identifier's name and its package name. Lean into that fact. Package level variables deserve longer identifiers than locally scoped ones because their scope encompasses the whole program. package globals are global to the whole program. And I agree strongly with Peter Bergon's statements on this, that really they have package global state has no place in any Go program. But if you're going to use it, make it descriptive. And lastly, don't follow the context example and blow a really useful identifier on the name of a package. So thank you very much for staying to listen to me. Please enjoy the rest of GoWayFest. I'm going to hand it back to Asim now and let him know that I'm done. I don't know how we're doing for time here, but I'm also available in the Q&A room after this. So thank you very much. I'm going to stop sharing my screen now so I can see if there are any questions. I'm going to try and stop sharing. There we go. Okay, so what happens now?
Okay, thank you very much for your presentation. It was really interesting, even though it's just about Go names, but you won't believe how it relates to me in terms of the code. More than I hate generics, I hate bad naming. We will go through Q&A now. We have a lot of questions and we will cover the popular ones. So the question about, I think, the user maps that we had in the beginning, how about the same concept but different data types? For instance, we have a slice of the users and a map of users in a function.
That's an interesting one. When I found that, I've done a lot of that kind of data transformation in Contour, which was the project I worked on until recently. We would generally be doing that kind of transformation. And what I really hoped, what I really wanted in Go, and hopefully we get this with Ian Lance-Taylor's work, is those kind of map and fold and flat map and inject style collection operations. Because fundamentally, you probably don't want, you have to give those variables names, especially if you have to write the loop out yourself from the select to like choose from a map, choose their names or something like that. But I wonder if we had better collection type operations, we could avoid those temporary variables. In the case such that it is, generally when you're working from one data type to another, like you're selecting keys out of a map or something like that, generally things like if you have from users to user names or something like that, it gets a little more verbose. The real key that I was trying to say there is that the name, like repeating the name of the type, like saying it's a map, doesn't tell you anything about how that map should be used. Rather than saying it's a user's map, say it's selected users, or if you're doing some kind of billing thing like to invoice or something like that, like use the opportunity for the name to describe the purpose of how it's going to be used, rather than just repeat over and over again how it was declared, I think is my advice.
Thanks. Next question about standard library, net URL path and file path. Should have they been renamed?
There's I'm trying not to speak too much for Brad. Brad has very strong feelings about I think he has somewhere like a Google sheet of all the packages and names and types that he would like to have fixed in the standard library. One thing to remember is that like this is the oldest Go code in existence, and at the time it was also the only Go code in existence. So people were really figuring out how to write it. And if you look in the standard library, you'll see a wide variety of styles, a wide variety of names, some that follow this advice. I mean, don't forget that like this is all contextual. Like I read Go code, I read other code, I go and buy old books and I look to them for advice. And so it's difficult. So this is perhaps not the most correct thing to say, but the standard library is kind of like the Bible. You can look at it and find an example for any argument that you want to make. There are examples that both support the arguments that I've made here and examples that that refute it. So in as much you should, I think you should read the standard library and read it as both a thing at a place in time. The reason why it's URL path is because people were still learning. Certainly, I think that the takeaway I would say, don't get so obsessed with renaming something that has been in use for 10 years. Take it as a learning experience, and when you're writing your own code, say, I don't want to make the same. I don't want to repeat what the way that URL path does. So I recognize the problem I had there. So that's my answer.
Yeah. The next question is about short package names. A problem from Vangelis Katsikaridis. Problem that I face sometimes with a package name, interface name, implementation name. Usually they tend to clash. Any suggestions? Probably to resolve that.
Well, I mean, my standard advice, which I've been giving for the better part of a decade, is people use too many packages. They really, really do. If you are finding that you can't find the right name for a thing in its own package, it is possible, and of course, not knowing your own situation, that there are too many packages in your code. This is now to justify this advice. I have seen this over 7 companies over that many years of writing Go. We all come to Go from another programmer, which is certainly anyone of my vintage. We bring the experiences we have from Java, my background, or before that was Pascal. Everyone brings their own experiences and with PHP. We all bring our own experiences of the things that made us successful in the past. And we want to say, well, I was a very successful JavaScript programmer. I was a very successful Python programmer. I'm going to start from the things that I know. And in those languages, things are different to Go. The advice that I try to give to people, and I try to encourage them, is don't make a new package. Certainly don't do the Ruby on Rails style of app, models, controller, whatever that nonsense is. Just maybe as your application grows, you will find a need for that structure, but don't jump to it immediately. And in that situation, when you have a limited number of packages, it can free you from the discussion about where do I put this? Does it go in that package or this package or the third package or the fourth package? And when you don't have to have that argument, you also don't have to have the, oh, I've created a circular import, because there's just one package. I realized that I really didn't answer the question. It's mainly because I think that question is very, very contextual. But if you're struggling to find the name of something within a package, I kind of get the little hint that there's probably too many packages in that project, and that would be the first place that I would look. But again, I recognize that's not a short answer to the question that you asked. It's a more kind of meta comment that almost seems like passing judgment, which I don't intend to do. So.
Great. Our Q&A session is coming to an end. If you have any questions to Dave, you could meet him in a speaker's room and ask and get answers from him in person. You could connect with your video and camera. Don't be shy, and you could just ask the question and discuss stuff. Maybe a couple of consecutive questions. So we will end the main Q&A session now, and feel free to join Dave in the speaker's room.
Thank you so much. Thank you.
Thank you.